Hi everyone, it is great to see everyone back in person. So my name is Ryan Jespersen, Director of Product Strategy at Dolby.io. And previous to that, I was part of a group that built a product called Millicast that was a real-time WebRTC streaming platform. And Dolby acquired us back in February. So really excited to be part of a brand that's known for quality and identity. It's been around in the broadcast industry for over 60 years. So today I'm going to focus a little bit on a side topic. We're at a broadcasting conference and we're going to talk about the metaverse. And I see many of you rolling your eyes out there, and I would have done the same thing about a year ago. But there's some amazing products that are being built that involve three different things. One, it's 3D game engines. The other is real-time video, and the other is spatial audio, which are becoming these kind of building blocks to build metaverse environments. So why is this happening? Why is this trend occurring? Well, I think it's obvious over the last couple of years that human nature craves interaction. Primarily brands want interaction because it leads to engagement. The more engagement, usually that turns into revenue, right? So one of the focuses at Dolby is to build this idea of virtual concerts or virtual stadiums for live music and live sports. And that's a lot top of mind for us right now to actually go and build the products that people need to build their solutions over the cloud and the web to enable those things. And that's what Dolby.io's initiative is we're trying to take Dolby IP and technology, put it into products that can be used to go to market very quickly in the cloud through live IP. So we're in Europe. You guys may not recognize Roger Goodell, who's in this picture, but he's the commissioner of the NFL, which is the National Football League in America. And he made a comment a couple of years ago when COVID was first happening that brands, especially content owners, need to find a way to engage with a younger audience. I'm now in my mid-40s. That's not usually the market that a lot of big brands are going after. They're going after a younger market, a demographic from 18 to 40. And this is a generation that's grown up with the internet, they've grown up with mobile devices, and they're actually very open to experimental methods of consuming content. And in order to do that, you need to build those products to go and generate revenue in the market. So the remote experience needs to feel real. So the things that we're focused on at Dolby is immersive, interactive, and social. And how can we do that for broadcast experiences? And we're very focused on live sports and live music. So some of the things that are happening here is, you can see an example here of a broadcast quality live concert being streamed into a 3D environment where virtual audience members can now participate and feel like they're a part of that experience. So, Elton John is going to be doing his farewell tour. There's only so many people who can go and buy a ticket to go and see him live. What about his millions and millions of fans around the world who want to be a part of that experience but maybe don't have access to it, or maybe can't afford to do that in a live environment? I think trying to find new ways to monetize really, really premium content is, I think, what the industry at large is trying to find, and I think COVID has kind of accelerated those journeys. Dolby Tomorrowland is a very large live music event that happens in Belgium every year. I'm a little too old to go to it. I don't think they even let me in. But we've found a way to actually do a live IP workflow for Dolby Atmos. So how can we pull in really high quality audio and sound for live IP for broadcast workflows, linear workflows? How can we use that same technology and that same method to pull in the idea of a virtual audience into a virtual concert or into an in-home experience that makes someone feel like it's interactive and immersive? I actually just went by the BT Sports booth yesterday, and if you haven't had a chance, you should go out there. And they're working on some amazing in-home experiences that make you feel immersed into a lot of the content that they're broadcasting linearly currently. So the idea of having a 3D map that maybe could be projected inside of your home so you can see MotoGP racers going around the track. You can choose kind of customized experiences where you can control which webcam you want to watch for your favorite rider, right? Or a Formula One experience, or a 360 camera. While you have a linear broadcast, you can choose a catered experience that you can interact with this content. How do you build this? It's not a linear method that the broadcast industry has been used to. We need to find new ways through technology to enable this, right? And a lot of times that happens on the edge devices, but how can we also engage fans, watch together parties, friends who are trying to consume content together and create that interactive experience? And similarly, BT Sport also created the ability to be in stadium, but interact with content and other fans in an in-stadium experience. So you have a lot of mobile telco carriers, right, who are creating deep edge computing that can be accessed by the actual stadiums themselves. So through 5G technology, we can now integrate some 3D worlds into in-stadium experiences to maybe create a higher level of engagement for both virtual fans as well as for in-stadium live fans as well. So this is one of the things I saw over at the booth with BT Sport. So this is actually live captured content that in real time is being rendered into a 3D game environment. This is also a live view of that MotoGP use case. So this is through an Oculus headset or a VR headset. You could be watching the live linear stream, you've watched the rec, now you want to look at the helicam live, right? And then similarly, you can look down and see where people are in real time on the map. So in order to do this, there are some components that need to be built to build this experience. So real life is in 3D, right? And what we need to enable this are 3D game engines. So there's an enormous evolution of products like Unity, like Unreal Engine, like Roblox. These game engines are creating the building block to create that real 3D environment that we need to interact with immersive content. So one of the things that we did at Millicast, which was acquired by Dolby, we created a plugin for Unreal Engine that allowed you to grab real-time rendered content inside of a game engine and stream it across the public internet at scale using a technology called WebRTC. So I would say probably 3 years ago, maybe even 5 years ago, you'd go around IBC and nobody knew what WebRTC was. I think that's changing. WebRTC is a technology that was originally built for real-time communication, right? That Google bought, open sourced, and enabled in the web browser to do live video conferencing. It's evolved now through vendors like us and other vendors who are adding a broadcast quality level and scale to the WebRTC experience, which prioritizes latency over anything else. With latency comes interactivity, right? With extremely low real-time latency. So our platform is able to do these things sub 500 milliseconds globally at scale, and we're doing more and more and more to bring that down to near zero latency, which can now create some enormous interactivity with these different products. So not only do we have a plugin that streams that rendered content from a 3D engine out, we can also grab real-time broadcast content or a webcam or any video source and stream it into a 3D game engine. So now we can do those kind of simultaneous environments to create any level of product that you're looking to build in the metaverse. So this is an example of a customer of ours that did something really interesting. Oz is based in Iceland, and they're just an example of kind of an up and running kind of technology vendor who's starting to work with technology that maybe a lot of broadcasters still haven't had a chance to experiment with. So this happened for the New Year's from this year, 2021 into 2022. Iceland has, I think, about 300,000 people, and they did this mass marketing campaign so everyone could feel like everyone I think was feeling very disconnected after COVID, after quarantines and so on. They wanted to unite the country in this live concert. So they had a very famous live artist in Iceland live stream, and what they did is they have an integration with Snapchat that will grab someone's Bitmoji with their permission, render it inside of Unreal Engine, control it through haptics, through the web interface that they have with Unreal Engine, a plugin called Pixel Streaming, and then that can get rendered out through a web experience, in this case through the Snapchat app in a web environment. So I know that was a lot of technology jargon, but this is really how it works. And I mentioned this previously, is Unreal Engine bought a company called Pixel Streaming a few years ago, and what Pixel Streaming had done is add WebRTC into Unreal Engine so the live rendered output could be rendered inside the browser. What we did is that couldn't really be done at scale. That was more for like a real-time confidence monitor of what was happening, right? So we were able to grab that WebRTC, pull it into the cloud and scale it. And that's the piece that we needed to really be able to use the same workflow for very large broadcast audiences. So kind of talking through this is a video from obviously my previous company that got acquired. Some of these assets are from Unreal Engine themselves, but what's interesting about this is how are we interacting with all kinds of content, not just in the broadcast industry, but to do remote post-production. You've probably seen the Mandalorian series. A lot of that post-production is happening remotely in real time as they render Unreal Engine to a 3D environment as they're broadcasting. So we work a lot with remote post-production customers doing that. You want to do live simulation with a customer halfway across the world and you're rendering it in Unreal. How can you do that in a broadcast workflow so they can have a good experience when they're looking at new simulations? So this is just a video that we saw of how we're grabbing that content from the Unreal Engine. And Unreal Engine is being used for live broadcast graphics. And this is just another example of how we're grabbing that live WebRTC stream in browser and scaling it across the public internet. So, why WebRTC? You guys may have seen this slide. I used to work at Wowza many years ago, and we put this slide together to kind of identify the market opportunity for real-time streaming. RTMP, I think we can all agree, is dead, at least from the distribution perspective. And it left a huge gap in the industry for how we deliver real-time experiences. And RTMP, even though it is in the name, it never really got sub 3 second end-to-end anyway. So we've always needed a technology that is web native, gets us sub-second so we can add that human interactivity element. And there are a lot of vendors, and there's a panel right after my session that's going to talk a little bit about LLHLS, CMAF with Dash, and other things that are trying to get there. But all of those are TCP-based technologies. WebRTC is UDP-based and is built for those incredibly fast streaming experiences. The other thing about WebRTC is we were part of the CTO at Millicast, my colleague, sat on the IETF committee. We were part of the team that helped standardize WebRTC as an IETF and W3C standard. It means any device that's now built for the internet and the web natively can support WebRTC. So what does this mean? Well, it means that billions of devices that are produced around every year have support for this technology natively. You don't need to wrap it in a player. You don't need to modify some kind of standard to get there. It's already there and it's built in. So it seems to be the technology that's most well positioned for delivering this sub-second experience. So we talked a little bit about the 3D game engine piece. We've talked about real-time video WebRTC. What's the final component that we really need to create a believable, immersive, interactive experience? And that's spatial audio. I think that where the kind of promise of interactivity is kind of falling short right now is, I think there's a famous saying by George Lucas that 90% of video is audio, right? Or 90% of the picture is audio. And it's true, if you've ever been part of a video conference and the audio is terrible, it doesn't matter how good the video quality is, we're going to skip it, right? And that's true of any kind of media asset. So one of the things, obviously being acquired by Dolby, pretty much the leaders in audio throughout the world. And there's a lot of technology that we're working on around spatial audio to create believable real-time mixes that are unique for every individual viewer that's viewing the content. If you're in a stadium, your viewing experience or your listening experience is unique to the person sitting next to you, right? You've got a fan shouting in this ear, you're going to get all of that. The person next to you not necessarily is going to get that same experience. So how can we create a spatial audio mix that emulates that kind of real-time use case? And most of what's happened, or the ways to kind of do that is we've got to limit the number of people you hear. You've only got to subscribe to the N number of closest voices. And you also have to work with predictable networking CPU resources on particular devices to make sure that you can mix that in a believable way. So those are the things we can kind of do. And then the other big piece is the ability to do a hearing range that's believable as well. So you want to render everyone within a certain distance. If someone's approaching you in a 3D environment, their voice has to be believable, right? And it has to come, and the volume obviously will increase. And obviously the spatial nature of 3D, in a 3D environment, you have to have a render engine that can work in real time. So how do we achieve this? And I'll skip through a couple of these. I kind of spoke through a couple of these slides. Well, the way the technology has been done traditionally, not just in WebRTC, but through a lot of use cases, is a peer-to-peer model, right? We're in a video conference, we're getting our audio through Zoom or whatever through anyone that's there, and there's no real mix happening. It's all, whoever's speaking, you're going to get that peer-to-peer mix. With the proxy forwarding model, okay, all of those audio streams are coming in, and there's a server who's doing some of the intelligence to send you a mixed downstream, right, to the end viewer. But what we're able to do at Dolby is the spatial mix where every single voice or music track can adjust in real time, and it's not a destructive output that's coming from that mixer. So that means that kind of technology can now be built into 3D game engines to create a believable audio experience that's unique for every user. So that spatial mixing server can also be done in software or paired with particular hardware devices, depending on your deployment, to create a lot of the technology. And to be honest, I've been in the broadcast and streaming space, kind of more of an expert in that space, expert used loosely. The spatial audio side, I'm so out of my element. I have my colleague Paul, whose company got acquired years ago, who specializes in spatial mixing, so I'm really happy that I can just go pass that information over to him. But some of the other things that Dolby does is obviously a ton of other IP that you can wrap inside of experiences. And not just talking about the vendor that I work for, but also just in general, what do we need? We need noise suppression. We need believable levels that can mix in real time. We need echo suppression. We also need a different audio chain for voice and music, right? If we're doing a Dolby Atmos stream in a live concert, we don't want someone's voice inside of a 3D game engine to be in our ear overriding this spatial, this Atmos mix, right? That's coming to us. So how do we do that? And what are the algorithms that we can build into the software to make sure that we're doing that in a good way? Also, as you walk around the stage, you're walking around the stage and you can hear the drum set over here a little bit more than you can hear something else. But in a virtual environment, you don't want to go all the way up to the speaker and just be blown out by the speaker, right? So how we do those mixes is slightly different than how it works in the real world. So in the time I have left, I love talking about customer use cases. This is one of our customers, Red Pill VR. They're based in Los Angeles. And we started chatting to Red Pill probably about 3 years ago at Millicast. And they were creating these beautiful 3D worlds in Unreal Engine. And they started doing resident sets with different DJs to actually come in and do these 3D concerts. The problem is this is all being done in a local environment. They would come in, like a lot of VR places that you've been to, they run local servers because the latency going over the public internet was just not enough to create a believable experience. So they were one of the first projects that we were able to successfully migrate from a local network environment to a public cloud environment with remote viewers. And they've done some pretty large-scale EDM events in the last few years. They specifically are very focused on the electronic music market. But obviously that you can do this both with VR. But another important thing is delivering this to 2D screens. You can create immersive experiences that are 2D as well, right? You don't necessarily need to include a VR headset into what you're trying to build with these broadcast workflows. And then another customer, this is slightly off topic from the broadcast market, but we're working a lot with people who are building 3D game engines, real-time video, and spatial audio. We're sitting here at IBC. Many people aren't able to attend. Obviously, we had to close down during the pandemic as well. What if we can create believable networking conference worlds for the business world through these same technologies? And I think this kind of migration of what you're seeing in the broadcast space, going into the business space, going into the gaming space, the underlying technology is the same to enable all of these workflows. So this company, Metaverse, is a customer of ours who is using the same workflow to build these 3D environments, specifically focused on the corporate market for creating this interactivity. One cool thing here is you can see they're actually able to grab real-time webcam feeds and render them to a 3D layer inside. A question I've actually got is how can we actually maybe get the facial recognition and map it in a much better way to a 3D sphere in real time? That's slightly out of my purview. It's more the technology can be built into the game engine themselves. And then another use case too is we're working with a company called Precision OS. They're doing real-time surgeries through a game engine where remote surgeons can collaborate in real time, take over a surgery, and experience these workflows through a VR experience. So these customers, even though this isn't traditionally a broadcast customer, they want broadcast quality video because they're obviously rendering really high quality graphics. They want a believable experience that allows them to launch a very successful product. So that's another place where, that gets a little bit graphic. I'll skip off. And then the other piece is inside of our Unreal Engine integration, we can grab multiple virtual cameras. So think you're at Coachella or at Tomorrowland and you're on one stage, but you want to get a quick preview inside of this 3D world of another broadcast stream that's happening on another stage. We can actually render out multiple virtual cameras from that Unreal Engine that's running in the cloud. And the important thing about what WebRTC is enabling is Unreal Engine is a heavy lift product. It's currently being run in Amazon Web Services, Google Cloud, different cloud vendors. WebRTC is enabling those renders to be delivered in real time to a thin client. So we have like mobile devices, we have smart TVs that don't necessarily have the compute power to render a 3D game engine, but we're able to get this with sub-second latency to be able to deliver that experience to a device that doesn't need to do the heavy lifting. So it's almost like a return to the 60s and 70s and 80s where we had the huge machines in the background and dumb terminals that were giving you the thin client experience. We're just emulating that, but in a media pipeline for 3D content. So I know that's a lot. It was a bit of a brain dump about what's happening in the metaverse space. There's an enormous amount of innovation happening, and I think we're going to continue to see more products like Unreal Engine, Unity, Roblox, a lot of 3D game engines that are getting in bed with broadcasters, real-time video and spatial audio to kind of create these experiences of the future. So thank you so much for attending, and I guess we'll open up to questions.